Blockchains are systems that allow different entities to share a database and keep track of transactions. A blockchain enables different types of activity and information to be shared between entities. To ensure legitimacy of the shared data, entities need to achieve consensus on the authenticity and validity of said data. This is done using something called a consensus algorithm. In the context of blockchains like Bitcoin, the proof-of-work algorithm is used as a mean to achieve a consensus between entities, which essentially translates to one entity doing some automated computer work to validate a bunch of transactions, and then other entities check to make sure that the work was done correctly. If everything checks out, then the first entity gets rewarded. To make this system secure, complex mathematical operations are performed, and it takes a lot of computing power to reach consensus between the entities participating in the blockchain. For individuals like you and I, proof of work can be expensive and make it difficult to participate in the system. Therefore, a system using proof of work may not be appealing because it requires expensive computer hardware to operate and a lot of energy. Additionally, from a security standpoint, proof of work-based systems rely on entities making transactions to invest additional resources, often called transaction fees, which can be costly and create a barrier to the types of transactions that can be made. For example, voting mechanisms can be a challenge to implement in a system using proof of work. Proof of stake is a method for achieving a consensus that is used in some blockchains, such as Cardano. Proof of stake generally relies on selecting a validator to provide a block, who is then eligible for a reward. The validator is typically selected proportionally to the amount of monetary resources they have invested, which can thereby limit benefits for less wealthy entities. Unfortunately, much like proof of work, proof of stake-based systems often rely on transaction fees to operate securely. An advantage of proof of stake when compared to proof of work is that it requires less energy to operate. However, due to the significant amount of resources necessary to invest in order to participate efficiently, proof of stake is far from flawless. Another way to achieve a consensus is with a method called proof of space. This is similar to proof of work, but mainly uses storage. An example of a blockchain using proof of space is one named Chaya. In a proof of space system, provers show that they allocate unused hard drive space for storage space in order to be eligible for a reward. To work efficiently, proof of space is often used with proof of time. Although it is an energy and cost improvement compared to proof of work, proof of space still consumes significantly more energy than proof of stake and requires significant monetary investment in the form of computer hardware. Like proof of work and proof of stake, proof of space-based systems also relies on transaction fees to operate securely. Although an interesting concept, it is therefore often seen as a less attractive solution than proof of stake, which, as we mentioned before, itself has its own important drawbacks. Therefore, as we established earlier, the main problems with existing consensus algorithms are that they often require a significant amount of one or more types of resources to operate, such as energy or monetary investment, and that the power of a given entity is generally correlated to how wealthy the user behind said entity is. This can limit decentralization by widening the gap between more wealthy entities and less wealthy entities. Inventions proposes a new consensus algorithm named Proof of Justice, which aims at eliminating those drawbacks. Inventions, high-tech research for curious minds.